Now let us see about carboxylic acids. Carboxylic acid, as the name itself suggests, is an acid. They have a acid property and they are having a functional group of COOH. Okay, a carboxylic acid, let us now see some of the names or naming of the carboxylic acid. We know the names right from say SCOOH, formal name, and then IUPAC name. This is formic acid. And this is oic acid, and all the carboxylic acids have the IUPAC name ending as oic acid, and depending upon the number of carbons, it will be meth, eth, like that. So here there are 2 carbons, so this is ethanoic acid. And this is formic acid, and then acetic acid. This is acetic acid. And in case if we have a dicarboxylic acid like COOH, so this is oxalic acid. Hence there are 2 carbon atoms. This is ethane dioic acid. Okay, ethane dioic acid. So here then you have a CH2 here, COOH. So this is a methylene group. So this is called malonic acid. So or 1, 2, 3 propane dioic acid. Okay, so if there are 2 CH2s, 2 CH2s, the 2 CH2s, they are going to be like, so this is succinic acid. Succinic acid has CH2 twice, COH, COH. And this is 1, 2, 3, 4 butane dioic acid. Since there are 2, nothing. So then we have okay, so this is glutaric acid. So glutaric acid is 1, 2, 3 plus 2, 5 pentane dioic acid. This is 3, this is 2 plus 1, 3 plus 1, 4. So butane. So this is pentane. Then we have this is adipic acid. Adipic acid or 4 plus 2 hexane dioic acid. Okay, now if we see some of the aromatic acids, this is commonly known as benzoic acid. And this is benzene carboxylic acid. Okay, so this is in case if it is an acidic group substituted here, as acetyl, or this is CS2COOH. So this is an acetyl group, so benzene, and there are 2 carbons, so this is phenylacetic acid. And if you have a 2 COOH groups, this is called the phthalic acid. This is the phthalic acid, and the common name, and this is the IUPAC name is benzene dioic acid. So these are some of the common names and the IUPAC names of carboxylic acid. The heading is carboxylic acids. Now let us see the preparation of carboxylic acids. Preparation of carboxylic acids. Okay. So the carboxylic acid are prepared from the primary alcohol or aldehydes on oxidation with KMNO4 in alkaline or acid medium. So this gives RCOOH. The same oxidation, if it is done in the presence of potassium dichromate, chromic oxide in acid medium, we also get the carboxylic acid. This is called the Jones reagent. Jones reagent. This is for aliphatic alcohols. In case if it is aromatic alcohol, you have to, and they have to undergo vigorous oxidation in the presence of KMNO4 and KOH, that is alcoholic KMNO4, vigorous oxidation. This gives COOK, which on further treatment with acid gives okay. So this is for aromatic carboxylic acids like benzoic acid. Then you can also be prepared from nitriles. Nitriles are actually on oxidation gives RCONS2. Okay, RCONS2, which on heating gives RCOOH. So nitriles are converted to amides. Nitriles are converted to amides, and these amides are heated to get the carboxylic acid. Then we have the fourth method is from Grignard reagent. This Grignard reagent, if it is treated with the CO2, treated with the CO2, you get the addition compound. You get the addition compound. This C double bond O, this C double bond O breaks to give H on hydrolysis gives our COOH. This is OMGX is getting added and R is getting added in other, and we get the carboxylic acid. Okay, so even it can be prepared from acetyl chlorides. You can take it to general acetyl chlorides. It can be aromatic or aliphatic or COCl. This on hydrolysis. Or COOH. Okay, again it is can be prepared from ester hydrolysis. Hydrolysis of esters. Esters are COO R dash. It can be aromatic and aliphatic esters. This also an hydrolysis. Gives RCOOH and ROH. So these are some of the methods of preparation of night. This actually happens in the presence of H plus or OH minus. Okay, so these are some of the preparations of nitriles. Preparations of carboxylic acids. So now let us see the properties of carboxylic acid. Properties of carboxylic acids. Carboxylic acid in general, the lower members are soluble in water. As the alkyl group increases, the solubility decreases. Lower members are the same. Mostly in vapor phase, many of the lower members of the carboxylic group exist as dimer, or they exist as a dimer in non-polar solvents. That they say is association. This is because of the formation of hydrogen bonding. So if you take RC double bond O, OH, okay, so even if it is CS3 COOH, you can take the specific example of CS3, CH3 COOH, and you take another molecule of CS3. This O and H have the bonding, and this H and O have a bonding. So they exist as a dimer.